Myself Arun Kumar from SNS College of Technology in the Department of EC. In this video, I am going to share about state models for linear discrete time systems. So, in previous video, we have discussed about state model representation of continuous time systems. So, this is the one of the type of state model system. So, it has been represented with the help of discrete time system. So, here the discrete means it has to be represented by a step-by-step process. Suppose if you want to take it as a sample means, then we can able to use this type of discrete time system for state variable analysis. Let me see how these presentations and representation to be made by using this video. Understanding the systems. So every model has some concentration and every models need to be verified by using some of the system. So here the concentration of those systems to be done by using the critical state variables and key points here given as slow response of the system, instability of the system, and external disturbance of the system. So these are all the key factors need to be concentrated while designing a state model representation of the system, so that the model to be mapped based on the input signal without any error or without any instability problem. So let me see how these statements to be considered and how the system has been evaluated. Pinpointing the core problem comes under defined part. So the main concentration is the mathematical calculation part, because the mathematical calculation part shows that how the state variable to be mapped with the help of input signals and how the state variables has been encouraged based on the systems of the corresponding variables. So how the mathematical systems to be represented and to be followed based on the input conditions. And next one is brainstorming control strategies comes under ideal part. So each one having different ideas to operate this type of discrete time systems, because discrete means we can be able to get the samples, more number of samples. So the samples to be done by using various methods like PID controllers. So the PID means proportional integral derivative controller, so that it will give exact result of the concerned input signals. And next one is feedback. Suppose if you want to add a particular part of the state variable means, then we can use this state feedback for the precise control process. And actually is optimal control for the performance. The optimal control means the maximized output to be followed by using this optimized control on their performance. And next one is simulating and testing solutions. After finalizing all those factors based on the input conditions, then we need to verify the result by using the simulation process. So here the simulation has been done with the help of three factors. First one is mathematical model, second one is simulation tools, and next one is test algorithms. So the mathematical models to be precise with the help of different input conditions. So once the input conditions to be matched with the state model, then it has to be verified by using the simulation tools. So here the simulation tools may be vary based on the different sample conditions. So the particular part of the input signal has to be simulated by using the simulation tool. Once if it is processed towards the end means, then it may be go to next step, testing the algorithm. So the algorithm means once the coding has to be finalized by using this simulation tool, then it is to be run by using the test algorithm. Once all the information has been fully verified, then it is processed and it has to be performed as output signals. And iterate and refining process. So after finalizing all those factors, we may got the final results. So these results are based on the graphical representation. Once we got the graphical representation method, we need to verify with the help of input and output signals, and we can verify by using the Kalman filter also, because the filtering process to be precise by using this Kalman filtering process, so that we can able to get the exact gain of the system. designing smart and robust control systems. After refining the state of the state variable systems, we need to integrate the approaches for various operations and applications, because we can able to forward these input signals for more number of operations, so that it is very much essential factor without getting any delays, and forward the information without any urgent. Mind mapping. So these factors are to be precise based on the design thinking approaches, because if you want to have a multiple number of information means, then we can use this mind mapping to get a exact solutions. Activity given as role play. The role play topic is smart traffic controller using a discrete time state models. The objective is to help students understand how state variables, state equations, inputs, outputs, state transition are used in the modeling and controlling a linear discrete time systems. Take a time of 20 to 25 minutes and make it as a group as 5 to 6 students, and then perform this role play. Assessment. The state space analysis generally perform in the frequency domain, time domain, Laplace domain, or Z domain. The answer is time domain, because the time only exactly is kind of describe about the state space representation. And next one is states variable must be independent of each state variables, dependent on the input, equal to the output, and constant with the time. The answer is A answer, independent of the other state, because the relationship to be done with the help of this state variable. These are all the references I have taken for this video. Thank you.